In this video, section 2.3, two-point form of a line. Now, what I want to do is I want to start with 2 points, say points 4, 3 and 6, 7. What I want to look at is how y changes compared to how x changes. Y ends at 7 and it starts at 3. So that's a difference of 4 units. It changes by 4. X ends at 6 and starts at 4. So that is a change of 2 units. So we could say that the ratio is 2. And this ratio right here is called the slope. And we would abbreviate it as m is equal to 2. And what it describes is how quickly y changes for a change of 1 unit for x. Never mind. And what it describes is if I take a line and I pass it through these 2 points, say something like this, then every change in 1 for x results in a change of 2 for y. In general, the equation for slope is where you end with y minus where you start divided by where x ends minus where it starts, and this is between the points x1, y1 and x2, y2. Now, these 2 points are enough to define a line. If another point is to lie on that line, say here, then the slope needs to be the same. If the slope isn't the same, then that point doesn't lie on the same line. So, let's take this slope relationship and introduce a third point. It's just going to be a general point, so we'll use x and y without the indexing. And remember, we want the slope relationship between our point in general and the first point to be equal to the relationship between the second point and the first point. And if this is true, if these are equal, then this point xy is on the line. This hypothetical line that connects these 2 points. But I don't like this form. I want to adjust it so that y is on one side and x is on the other. So what we'll do is we'll get rid of this denominator, and we'll do that by multiplying both sides of the equation by the difference x minus x1. The golden rule says that we have to multiply both sides. Otherwise, we're performing an operation on just one side of an equation, so it's not equal to what we had previously. These cancel out, and we're left with y minus y1 is equal to the change in y divided by the change in x times the quantity x minus x1. And yes, these parentheses are important. And this equation right here is called the 2-point form of a line. How would we use it? Well, let's suppose we're given 2 points, 3, -1 and 4, 7. Then the line between them, so we're going to find the line that passes through both of these points. And to do that, we're just going to plug in the values. So this is our first x point. This is our first y point. This is the second x point, this is the second y point. And they're just going to go in their respective spots up in this equation. So to start, we'll have y minus y1, which is a negative 1. And that's going to be equal to y2, which is 7, minus y1, and that's going to be divided by x2, which is 4, minus x1, 3, and we're going to multiply that by, let's see here, this difference, x minus x1, 3 again. And that's the equation for this line. But we can go ahead and we could simplify this a little bit. Say we could write that as y plus 1. Likewise, this would be 7 plus 1 over 4 minus 3 times the quantity x minus 3. That's a little bit cleaner. Now, could we take this fraction right here, write it as 8 over 1, and then just simply replace it with 8? Sure, we could, but that would be a different form of a line, and that's the next section. See you then. Thanks.